Greetings and welcome to your Algebra Week 16 recording. We are in Week 16. It's the first week in May, and the last day of school is also in May. So just a heads up, but we are quickly approaching the end of the school year, which is super exciting. We're about 4 weeks out, maybe a little bit less than 4 weeks out. Just wanted to bring that to your attention so that if you have a goal in mind for how you want to end the course, you're working towards that goal and aware that the end of the year is coming up pretty darn quick. So that's pretty exciting news. So let's start with a warm-up. We are moving into a new unit this week. Before we do that, though, you will be taking the Unit 8 test this week. But I did want to start the recording this week with a warm-up. So make sure you've got your math notebook out. If you don't, remember you can click pause and grab your math notebook and come on back and join us and take good notes, because you do need to turn these notes in with your Week 16 notes. So for this week's warm-up, you are going to simplify this expression, 3x plus 6 minus 2x plus x plus 10. So simplify that expression by combining the like terms. So go ahead and click pause and try this warm-up on your own in your math notebook, and then you know the drill. When you're ready to check your work with mine, go ahead and click play. But go ahead and click pause now and try this on your own first. All right, so first let's identify our like terms. So I see a couple x terms, and anything that has an x is a like term. So I'm going to go ahead and circle my x terms, and notice that I circled the negative because that's part of that 2x. The fact that it is a negative 2x. So how many x's do we have? So we've got 3x, take away 2x. So now I've got 1x, and then I'm adding to it another x. So that gives us a grand total of 2 x's. What about our constant terms? So those are our whole numbers. So I see that I've got 2 whole numbers here. I've got a positive 6 and then a positive 10. So we're going to add together 6 plus 10. And that gives us a total of 16. So see how I was able to go from 1, 2, 3, 4, 5 terms and end with only 2 terms by combining my like terms? So that is why we simplify, is to make it so that we're dealing with less terms by combining all of our like terms. So that's our final answer, 2x plus 16. I'm going to move on, so if you need more time here, go ahead and click pause. So this week, we are going to take the Unit 6 test, so you'll have some time to review, redo low-scoring assignments. This is, note, because we're taking the Unit 8 test this week, this is the last week to submit redos for Unit 8. So this is the last week to submit redos for Unit 8. So make sure that that's a great way to help you prepare for the Unit 8 test, is to go back, A, make sure that you turned in all your work from Unit 8, and then B, submit redos, redo any low scoring assignment. And I suggest anything under a 70% that you redo. And then we're going to move on to Unit 9, which is all about looking at measurement, two-dimensional shapes, three-dimensional shapes. We'll get into finding surface area and volume. Session 1 is a little bit longer, so I suggest that you spend maybe 2 days completing Session 1 this week, and that's why it's kind of a smaller list of assignments for this week. All right, so moving on to perimeter. So we're going to start Unit 9 with learning about perimeter, and I know many of you are very familiar with perimeter already, but we're going to take it maybe a step deeper this week. So perimeter is just when we add up all of our side lengths. So it's the distance around the outside of a two-dimensional shape. So that is perimeter. A lot of times we'll have length and width. So if we have one side labeled W for width and another side labeled L for length, so to find the perimeter, then we can create a formula, right? So to find perimeter, we would add up. Perimeter would equal length plus length, because to find perimeter, we're just adding up all the side lengths. And then we can simplify that, right, by combining our like terms like we did in our warm-up. So 2L plus 2W. So 2 times the length plus 2 times the width. That is perimeter. And a lot of people like having formulas to make things easier. So that is our formula for perimeter. 2 times the length and plus 2 times the width. So we've got an example down here. I've got a rectangle with 2 values, 2 side lengths that are labeled. We've got this length right here is 12 centimeters and this side length right here is 9 centimeters. So one way of finding the perimeter would just be simply to add all of our side lengths together. We could say, okay, if this side is 12, I know this side also has to be 12. So I could say 12 plus 12. If this side is 9, the side opposite has the same length as well, so it must also be 9. And then I would add 9 plus 9. Add all those together. So I know 12 plus 12 is 24 plus 18, 9 plus 9, gets a grand total of 42. And we do need to include our units of measurement, and that would be centimeters, just plain old centimeters, not squared because we're not using area. We're just adding the outside lengths together, so it would just be plain old centimeters. We could also find the perimeter by using our formula. So let's use our formula. So remember, perimeter equals 2 times the length plus 2 times the width. So we would have 2 times 12 plus 2 times 9. And that's going to give us the same answer, right? 2 times 12 is 24 plus 18, which gives us 42. So the perimeter is 42 centimeters. So it doesn't matter which method you choose to use, we get the same answer, right? So just wanted to show you that and how we get the formula to find perimeters. 2 times the length plus 2 times the width. All right, so moving right along to what if you are given your perimeter with side lengths of variables? So we can still find the perimeter, we're just going to have variables involved in our answer, just like we did when we did the warm-up where we dealt with variables, simplifying. Same thing's going to happen here. So just because we have variables doesn't mean we can't find the perimeter. We're still going to find the perimeter. We'll just have variables in our answer. So here we can see that we've got a rectangle. This side length here is represented by x minus 1 inches. The IN represents inches. This side length is x plus 4 inches. So what's the perimeter? Well, let's go ahead and calculate that. So one way we could do it is just by adding up all of our like terms. So we would have x plus 4 plus x plus 4 plus x minus 1 plus x minus 1. So let's find all of our like terms. So all of our x terms, we've got 1, 2, 3, 4 x's. 4 x's together, we have a total of 4 x's. And then let's add together all of our like constant terms. So we've got 4 plus 4 is 8, minus 1 minus 1. So 8 minus 1 is 7, minus another 1 is 6. So our final answer would be 4x plus 6. That's the perimeter. And we could put that in parentheses so that we could put inches in there too. We could also use our formula, no big deal. We can just say, well, I know there's 2x plus 4s, and I know that there's also 2x minus 1. So if I use the formula method, I would have to distribute. So I would have 2x plus 8, right? and then plus 2x minus 2. And then combine the like terms from here. I've got 2x plus 2x is 4x. And then I've got 8 minus 2, which gives us 6 inches. So same answer, just two different methods. And that's what's always so cool about math is we usually have more than one way to arrive at our answer. Let me put up some more variables. Let's say that I've got this triangle down here and I just put in some values. They've got variables and we want to find the perimeter. So how would we do that? So we're just going to add up all the side lengths and combine any like terms. So here perimeter would equal, so now perimeter, since we're not dealing with a rectangle, we can't use that 2w plus 2 length. So we're just going to add up all of the side lengths. So it's just going to be 3x plus 12x plus 5x. And then they're all x terms, so they're like terms, so we can add the coefficients. 3 plus 12 is 15, plus another 5 would give us that 20x. And that's our perimeter. And whatever units of measurement, it would just be units, whether it's inches, centimeters, meters, whatever that is. And that would be our perimeter. So moving on to the next slide, if you need more time, go ahead and click pause. So what about finding the lengths if we're given the perimeter? So now let's kind of work backwards. So let's say that we're given the overall perimeter and one of the side lengths. Then we can use our algebra skills to find the remaining side length. So let's look at an example. It says a rectangle has a width. It has a width of 8 feet and a perimeter of 32 feet. And we want to determine the length of the rectangle. So the width is 8 feet and then the overall perimeter is 32 feet if we add up all the side lengths. So we know if this side here is 8, this one also must be 8. But we don't know these two lengths, right? So let's use our algebra. Let's use our algebra and the formula that we came up with earlier. So the formula for perimeter of a rectangle is 2 times the width plus 2 times the length. Well, remember, we're given the width. The width is 8 feet. So I'm going to substitute into my formula the given values. So 2 times 8. Instead of putting W, I'm going to put 8 because we're given the width. And then remember, we're also given the perimeter. The perimeter is 32. So I'm going to go ahead and put 32 in for the P and then plus 2L. So let's simplify this. Let's do the math. Let's do 2 times 16 or 2 times 8, which is 16, plus 2L. All right, so now we're going to use our algebra skills and the fact that we want to solve for L. So to solve for L, what do we do first? We're going to subtract 16 from both sides. So 16, 32 minus 16 is 16 equals 2L. And then our last step for solving for L would be to divide each side by 2. And I get 8 equals L. So in this case, it was actually a square, wasn't it? If the length is also equal to 8, that would mean that all sides are equal to 8, and it would actually be a square. But the important part is that we found the length is 8, and we would also want to include L equals 8 feet. You always want to include your units of measurement. That is part of our answer. So pretty cool, right? We're able to use our algebra and how to solve for variables to solve for this type of a problem. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. Moving on. So we are going to now start looking at finding area of parallelograms and triangles. We're going to look at finding the area. But before we learn the formulas to find area, one of the aspects of the formula for finding area of parallelograms, rectangles, and triangles is height. Height is always involved in both those formulas. What's important is that you guys recognize that to find the height of a parallelogram, or a triangle, the height has to form a right angle with the base in order to be considered the height. So this right here, because it forms a right angle with the base, or I could draw it in right here, this could be the height, this could be the height. The height has to form a right angle, a 90-degree angle with the base. This side length here is not your height. This is not your height because it doesn't form a right angle with the base. So in order for the measurement to be the height, it has to form a right angle with the base. Same with a triangle. This side here would not be the height, nor would this side be the height of our triangle. This instead would be our height because it forms a right angle with the base. So remember, in order to be able to use the height in a formula to find area, that side length, the height, has to form a right angle with the base. And we're going to look at some examples of that. All right, so here is our triangle. There's our height. It would have to be this distance here because that forms a right angle with our base. Again, here's another triangle. The height would actually be measured from here to here because that would form that right angle with the base. All right, so ready for the area formula? This is probably a review. The area formula for a triangle is 1/2 the base times the height. So multiply that base length times the height, get that product and divide it by 2, and then you've got the area. Area, heads up, the units for area are always squared. So like if you've got a measurement in feet, the area would be feet squared. If it's meters, it would be meters squared. If it's inches, it would be inches squared. You get the idea. But just a heads up, the units for area are always squared. So write this formula down in your math notebook that the area for triangles is 1/2 base times height. And we're about to use that formula. Ready? I'm going to move on. So if you need more time here, go ahead and click pause. All right, so go ahead and find the area of this triangle. Remember, area is base times height. Oops, 1/2 base times height. So if you want to try this on your own, go ahead and click pause and then check your work with mine. It's a great way to be more interactive with the recording. All right, so what is the base? The base is from here to here. So the base measurement is going to be 12 inches. What is the height? Is it from here to here? No, it's got to form that right angle with the base. So 8 inches is going to be the height. So the h is going to equal 8 inches, that distance from there to there. So I always start with writing down the formula first. So I'm going to write out a equals 1/2 base times height, and then I start substituting in my values underneath. So the base is 12 and the height is 8. So to find the overall area, what I like to do first is multiply the base times the height, so that 12 times 8, and I get 96, and then I just take 96 and divide it by 2 to get the final area, which is 48. So the area equals 48. If I just said that as my answer, would I get full credit? No, I need to include units of measurement, which is inches squared in this case. All right, moving on to the next slide. So if you need more time, go ahead and click pause. Parallelogram, even an easier formula. The parallelogram formula, area equals base times height. We don't have to divide it by 1/2. Remember, height has to form that right angle with the base, and you're good to go. So write down the formula for parallelograms, and this is actually the same for rectangles as well, if you want to note that in your notes. Rectangles, to find the area, it's also base times height. All right, so let's work backwards, just like we did when we were given a perimeter and we wanted to find the length. So we can also work backwards using our algebra skills and the formulas that we're given to work backwards, such as this question when it says find the base. So we don't know the base. The base is unknown. Find the base of a parallelogram if the area is 96, so we know the area, I'm just going to write down what we're given, is 96 inches squared, and the height is 8 inches. and we want to find the base. We don't know that. So let's use our algebra skills to help us solve this. So we know the formula is area equals base times height. Always start by just writing the generic formula without anything in it, just the variables. And now let's plug in our given information. So instead of A, we're going to write 96. The base we're trying to find, so I'm going to keep that as B, and the height is 8. So 8 times B. So we want to use our algebra to solve for B. So how do we do that? We divide each side by 8. And that gets us our answer that B is going to equal 96 divided by 8, which is 12. And again, we always want to include units of measurement, and here it was inches. So the correct answer would have been C. All right, and I think that about wraps up what we wanted to learn this week. We are doing the week 16 key phrase. I'm going to put up the week 16 key phrase question. Give me just a moment. Here we go. So the week 16 key phrase assignment. If the perimeter of a rectangle is 40 centimeters squared and the length is 4 centimeters, what is the width of the rectangle? And I drew a little diagram to help you guys get a visual to solve this if you need that. You might not need that, that's okay. Remember to use units of measurement, include that in your answer for full credit, and that's it. So if you need any help, let me know. I just updated those directions down here to make sure they said algebra in week 16, and that's it. Have a great rest of your week.